Launching an aircraft from an aircraft carrier is more intricate than simply pushing a button. It involves using powerful catapults and quick responding braking systems beyond communication between the pilot and the ground crew. The catapults are crucial in accelerating the aircraft during takeoff and assisting the pilots. So, what exactly are these catapults and how do they function? Let's explore the happenings on the flight deck to find out. The aircraft director oversees all aircraft movements on the flight deck and directs the plane onto the catapult. As this happens, the person in charge of this task lifts the jet blast deflectors. At the same time, the launch crew is adjusting the steam pressure of the catapult by either making it higher or lower. A weightboard operator shows the pilot a board that says how much the plane is estimated to weigh. The Integrated Catapult Control System, or the launched bubble, holds immense significance during aircraft launches. The topside safety petty officer expertly directs the launch bar into the shuttle tracks, while the holdback operator securely holds the aircraft. Once the catapult is programmed correctly, the catapult control operator indicates the first ready sign. The pilot proceeds with final checks before going full throttle, giving a respectful salute. The shooter's hand signals readiness while the launch officer inspects the flight deck for clearance. This step is crucial, as anyone in the path of the aircraft has no chance of survival. If all is well, the launch officer gives the thumbs up, crouches down, and points forward. Next, anticipation arrives as the remote catapult operator presses the fire button, propelling the aircraft to 160 knots in 2 seconds. Will the skilled crew and advanced technologies employed on aircraft carriers be enough to overcome the inherent dangers and launch aircraft safely into the air? Or will one misstep lead to disaster? While the flight deck may resemble a conventional land runway, the intricacies of aircraft carrier operations lie beneath the surface. With a high volume of landings and takeoffs taking place within a confined space, one misstep could lead to disastrous consequences, as the powerful engines of fighter jets have the potential to suck in or hurl someone overboard in a split second. To launch aircraft into the air, high-pressure steam catapults are employed, functioning like massive springs that release upon command. However, with the advent of modern technology, electromagnetic catapults have taken center stage. The crucial element that enables an aircraft to soar through the air is the lift generated by the wings, and occasionally the aircraft's body, when there is sufficient air surrounding the wings. While some aircraft carriers rely on ski jumps and internal propulsion systems to launch planes into the air, others employ more advanced catapult systems. Aircraft take off by converting the pressure difference between the air above and below their wings into the lift. On an aircraft carrier, this airflow is generated by the aircraft's forward motion on the flight deck. Advanced aircraft carriers use systems such as catapults to accelerate the aircraft to takeoff speed, while others rely on ski jumps and internal propulsion systems. The USS Nimitz, for example, employs the C-131 catapult, which is 99 meters in length with a stroke of 94 meters and can achieve significant speed in a relatively short distance. Its capacity is 36 tons at 140 knots, whereas some other aircraft carriers use catapult systems with lower capacities, such as the C-133 catapult on the French nuclear aircraft carrier. The Charles de Gaulle carrier employs a catapult system that has a stroke of 75 meters and measures 80 meters in length, and it can handle a weight capacity of 27 tons at 140 knots. Various techniques like sleds, weighted objects, and wheeled devices are utilized to evaluate the speed and effectiveness of different aircraft catapults. For an aircraft to launch off the carrier, it must go through a sequence of phases including restraint, tension, drag, roll, and free roll, where the front landing gear of the aircraft is connected to the catapult equipment. During the tensioning phase, the catapult tackle and rod restrain the front landing gear. The drag and roll phase involves disengaging the front landing gear from the restraining rod, which propels the aircraft forward at high speed. These phases mark significant differences in the system and play a crucial role in successful aircraft launches. Are there any potential disadvantages or limitations to using electromagnetic catapults, and how are these being addressed by naval engineers and researchers? As the catapult block pulls along an aircraft, it enters the free-rolling phase when its nose gear is released from the catapult tackle. It then hurtles off the aircraft carrier's deck at the end of the catapult stroke. However, Steam-powered catapults are rapidly becoming outdated in the 21st century due to their massive size, the manpower required to operate them, and their inability to cope with increasingly heavy aircraft. As a result, electromagnetic catapults, known as EMALs, are taking their place. These advanced launching systems have been successfully developed and installed only in the United States and China. They are operational on the Gerald R. Ford-class aircraft carriers in the United States and the Chinese aircraft carrier Fujian. The catapult has come a long way from ancient warfare to modern naval aviation, but the latest iteration of this technology takes it to a whole new level with linear induction motors. The system uses linear induction motor-powered catapults instead of traditional steam pistons to launch aircraft from naval carriers. These electromagnetic catapults offer multiple benefits over their steam counterparts, including improved reliability, reduced workforce requirements, and less stress on the aircraft structure. Unlike steam catapults, which require varying amounts of steam depending on the aircraft's weight and cannot be adjusted once launched, electromagnetic catapults feature a launch control system that monitors and adjusts the launch speed to within 3 miles per hour of the intended takeoff speed at any point during the launch sequence. These advancements provide a smoother, more efficient launch process for carrier-based aircraft. Shipboard electromagnetic catapults are a prime example of modern technology revolutionizing naval aviation, providing carrier-based aircraft with safer and more efficient launch capabilities. These shipboard electromagnetic catapults are based on enormous linear induction motors that consist of 3 primary components: 2 fixed beams or stators that are 300 feet in length and spaced just a few inches apart, and a movable shuttle or carriage that is 20 feet long and is sandwiched between the 2 stators. The carriage can slide back and forth along the length of the stators and is responsible for propelling itself. The stators themselves comprise many individual segments, each with wiring that can be turned on and off as needed to generate an electromagnetic force that propels the carriage. By selectively energizing parts of the stators in a specific order, the system creates a magnetic wave that propels the carriage forward. Unlike traditional linear induction motors, this system only energizes the segments directly adjacent to the carriage, producing an attractive force at the front of the carriage and a repulsive force at the back. This design allows for an efficient and controlled aircraft launch from the ship's deck. The carriage and the plane are connected by the airplane's nose wheel landing gear, which uses the same hardware as the steam catapult system. Once the plane is attached to the carriage, electricity moves it up and down the catapult, sending it into the air. The electromagnetic catapult can generate enough speed to launch the aircraft at 200 miles per hour in 3 seconds. It uses up to 1 million watts of electricity, the same amount a small town uses in the same amount of time. But taking off and landing on a battle carrier is a complicated and dangerous process that requires aircraft to have their engines running before launch. Even though it might seem possible to use catapults to launch and land all planes to save space, this is only a good idea for smaller planes because it is likely to fail. In the end, electromagnetic catapults are a powerful and effective way to launch something, but it is crucial to consider their limitations and possible risks. That'll be all for today's video. We hope you enjoyed learning about the fascinating world of electromagnetic catapults. Let us know your thoughts on the topic in the comments below. And if you found this video informative, please consider subscribing to our channel and hitting the notification bell to stay updated on our latest content. Thank you for watching, and we'll catch you in the next one.